how much is. In this table, if we know water ratio E, we can read out how much is K2 max. If we know relative density R, we can also read out how much is K2 max. And do you know the relationship between the E and dr? Dr relative density can be calculated by the current water ratio E. Is equal to E max minus current value E divided by E max minus E minimum. E max is the maximum value of water ratio of one kind of soil, and the E minimum is the minimum value of water ratio of the soil. Seed also did some research of the shear modulus. In general, the shear stiffness of saturated clay increases with the increase of strength. Under static condition, the ratio of shear modulus to engined shear stress SU of various saturated clay soil has little change. For example, for saturated clay, the maximum shear modulus can be expressed as the Gmax equal to 2,300 SU, engined shear strength. For fine clay, the ratio Gmax over SU of maximum shear modulus Gmax to engined shear strength SU can be estimated by plasticity index IP and over consolidation ratio OCR according to empirical relationship recommended by Valley and listed in the next table, where the engined strength SU is. Here, this is the ratio of Gmax over GS. If we know OCR and IP plasticity index, then we can read out this ratio in the table. This table proposed by C. Anderson's research. In addition, the shear wave velocity or Gmax increases approximately linearly with the logarithm of the time after consolidation, and the degree of increase cannot be attributed to the compression effects alone. The change of stiffness with time can be expressed as delta Gmax equal to NG. In fact, is NG, subscribed is G, times the Gmax 1000. And here, delta G is the increment in logarithm times cycle, and the delta G max 1000 is value of delta G at 1000 minutes after the end of consolidation. Kokushio Koji, Japanese scientist, and his teams point out that NG increases with the increase of plasticity indexed IP and decreases with the increase of the OCR. For normally consolidated clay, it can be estimated according to the following relationships: NG equal to 0.027 square root pi. let's see the table of empirical relationship Gmax and in situ test parameters. We can use SPT test and Ota and Goto. They are Japanese scientists. They proposed empirical relationship for sound. Gmax equal to 20,000 n SPT number and times the sigma m prime powered negative powered 0.5 and seed and imai tonouchi also propose empirical relationship of sound. Gmax equal to 325 times the number of SPT powered 0.68. And we can also use CPT test result. Rees and Stockel proposed formula empirical relationship of cause sound. Gmax equal to 1060-34 times GC powered 0.25 times the sigma V prime powered 0.375. And Baldi and his team and Magni Riggs they proposed empirical relationship of clay. Gmax equal to 406 times GC powered 0.695 times the E powered negative 1.13. And DM test also valid is a lateral expansion test. Baldi and his team proposed an empirical relationship of sound using this equation. Gmax divided by ED equal to 2.72 plus or minus 0.59. They give a range, in fact. And Bolody and his teams proposed an empirical relationship of sound. Gmax over ED equal to 2.2 plus or minus 0.7 is a range. And receive